So I've got me my scatter plot, and I want to make a prediction as to somebody's result, to another result. Let's say I'm going to use my usual example. Brittany Lynn has not yet taken the SATs, and I want to take a guess as to what her score is going to be. Well, what I'm going to do is I'm going to try to draw a line that goes basically through the center of all the points, and try to use that to get myself a decent guess that's going to be at least close to what her actual SAT scores are going to be. Let's take a look at this. If I draw a line more or less through the center of this, a straight line through the center of this thing, maybe it should have been a little bit higher at that end, but basically then I say, well, so I met your uncle and he's 55 and he's married, and I know nothing else about his wife, but he mentions that he's married. My best guess for her age is 53 and a half. So, yeah, I'm probably going to miss by a little, but at least I have my best guess. What makes it best? What makes this line the best possible line? We'll get to that in a bit, but a regression line, as an idea, is a line that goes more or less through the center of the points that you use to make a prediction. The point is, you use that line and your explanatory variable value to make a prediction as to the response variable's value matching for that point. I've met a whole bunch of runners, and I know that taller runners tend to take this long to run the marathon, shorter runners take this long to run the marathon. I have a line of all of them. Well, I'll make a prediction as to when this person will finish based on their height. If height is a good predictor, I'll be close to the truth. If height is not such a good predictor, I'll be further from the truth. Yeah, higher R values mean that your regression line, if you do it right, will be more predictive. Over here, ditto, I draw a line that goes vaguely through the center of the points. And there's a regression line. Is it the best regression line? Let me draw you another regression line. This is not a particularly accurate regression line, and there is an optimal regression line, the best possible regression line for the data, which I'll get to a little later in this video. The point is, you draw a line, and then you say, oh, the driver is 55, well, I bet that they will be able to recognize the sign from 380 feet away. And you want, of course, the best possible line, which is why the following things were developed. Okay, oh yeah, let me make one point about what a residual is. A residual is how much your prediction missed the truth by, or how much the prediction line missed the truth by. In these examples, let's take this regression line here. Boom. Okay, straight line always, by the way, at least in this course. Yeah, let's not do late college stats in pre-college. So let's say I have a person who is 60 years old and their wife is 63, 64, something like that. Great. Here we have a 60-year-old man married to a 65-year-old woman, 63-year-old woman, and we say, this point, or this couple, had a residual of however much they missed our prediction by. So this person has a positive residual. We thought the wife would be 56, but she's actually 63. So based on the man's age, we missed the mark, and they're actually, this is a positive residual because it's above the regression line. Positive, whatever that is, looks like positive 6. So the value of this residual is positive 6 years, I guess. Here we have somebody with a negative residual. And yeah, residual is distance from the regression line, and it also includes direction. So this is a positive residual. This point has a negative residual. Yeah. It's how much you missed the line of prediction by going straight up, down. It's how much we missed the response variable by. How much the actual response variable missed the predicted response variable by. Alright. So you can draw a regression line. I can draw a regression line. We can all draw regression lines for, give me a scatter plot, boom, done. But there's one sort of best possible regression line, and there's lots of ways to consider what makes a line best possible, but there are several about the least squares regression line that make it the one everybody uses for this business. It minimizes the squares of the residuals. Let me illustrate this with a little picture here. Let us say that I am predicting height based on weight. And for simplicity's sake, I'll assume there's only 4 points. Point, point, point. Oh, actually, that doesn't make any sense. Let's make it be a positive correlation. So here we have 2 people who both weigh 120 pounds, and they are 5'4", so 64 inches. Actually, one of them is just an inch below that, 63 inches. And one of them is, let me erase this. One of them is 5'3", 63 inches, and the other one is 65 inches, 5'5". And then we have 2 people who weigh 180 pounds, and they are 5'10", and they are 6 feet tall. Our line of best fit in this case would be, well, let's see, if I make it go through this point and this, let's say I want to get the points as close to the line as possible total. Well, why not just draw it through 2 of the points? This point misses by 2, this point misses by 0, this point misses by 2, this point misses by 0. Average missing, 1. But of course, there's a lot of ways to do that. I could also draw the line a little steeper. Oops. Misses by 2, misses by 0, misses by 0, misses by 2. Just as good. And so in order to get right between those 2 points, and right between those 2 points, they had a choice. Well, no, they didn't have a choice. The reason this works best right between them is because instead of a distance of 0 and a distance of 2 and a distance of 2 and a distance of 0, they can get a distance of 1, 1, 1, and 1. What makes these better than these? I mean, you can see that that's a better line because it goes right through the middle of the 4 points. But what makes this better is that when you square all of the numbers, this comes out to 8, and this comes out to only 4. So this is a better line. That's why they use least squares. They make the squares of the residuals as small as possible. They could use simply absolute value of the residuals as small as possible, but then it could be any line in between or on the points. If you tried to minimize the residuals, well, I'll just draw my line way up here, and these residuals are all negative, so it minimizes the residuals. So yeah, least squares. The squares of the residuals are as small as possible. And then it fits in with other things like R in really neat and unexpected ways. It's like, oh, what a coincidence. They did, for those of you in pre-calc, just like trigonometric identities, you prove that one thing is equal to another. Weird thing equals other weird thing. Huh, who would have guessed it? Over here, they basically found that creating the least squares line also gives R, which we had in the previous video, new useful meanings that relate to the scatter plot. We'll come back to that later. Here I just grabbed a scatter plot off the net and a regression line, the least squares regression line. You'll notice that it's not exactly necessarily what you might have gone for. You see this one point at the upper end over here, you'd have thought that the line would get a little closer to this point. But if you do this, apparently points like this have very large residuals. And yeah, that makes this residual smaller, but overall it's not as good. The residual, a lot of the residuals here to the line they drew are going to, on average, have their squares smaller than that line that I drew. The line they drew is the best possible line as I would define it, the least squares regression line. Okay, let's talk about what this line doesn't do. You notice how there's 1, 2, 3, 4, 5, 6, 7, 8 points above and only 7 points below? The least squares line does not make sure that there's the same number of points above and below. And my best example of this would say, let's say you have a whole bunch of points like so, and then like 1, 2, 3, 4 points like that. The least squares regression line would probably run like this. A lot of small positive squares and a few large negative squares. The point being, if they brought it too close to here, there'd be so many numbers with their squares all rising that would make things better. And it's like the difference between, why isn't it right on these points and hell with those 4 points? Because if I drew it right through, then I'd have like 0 squared plus 0 squared plus 1 squared plus 0.5 squared plus 0.8 squared, and 0.5 squared is really not very big. If I move it a little further down, yeah, now it's 1 squared, 1.2 squared, but those are still pretty small. And just for increasing those from like 1 squared to 1.3 squared, I've managed to reduce these from like 10 squared to 9.4 squared. And that makes the squaring makes a big difference for bigger numbers than for smaller numbers. So yeah, it will not always have the same number of points above it or as below it. It doesn't try to go through as many points as possible. It's not about hitting every point exactly. Usually a regression line will miss every single point. It's not going for right on points, it's going for right in between the mass of points. And it often feels a bit too shallow. Like you saw the line I drew and how it sort of felt better, but the original one was better. The regression line often feels a little bit too shallow, like not steep enough, pardon me. So here's the data from the class, from our class, comparing SAT scores and here's SAT scores and GPAs. Specifically, GPA is the explanatory variable and SAT scores is the response variable. And you see our line is pretty shallow, right? It's not particularly steep. So if somebody has a 3.5, if a new kid switches into my class, or some kid I don't know, also taking AP Stats with Mr. Murphy or whatever, if he taught it, and I know their GPA is 3.5, my best prediction for their SAT scores would probably be 1200. If somebody had a 5 GPA, my best prediction for their SAT scores would probably be 1220. It really doesn't seem to make a very big difference, but this is a better prediction than the original. Now I will fast forward and come back to this. No surprise, regression lines look like equations of lines, right? Only they reverse, instead of writing mx plus b, they write a plus bx. They start with a because it's got x with 0 power, and then b because it has an exponent of 1 power. Don't ask me why they decided to rename them this or why they decided to reorder them. I actually think this order makes more sense. Like, you start at the y-intercept and then you rise at the pace of the slope. So this makes more sense to write it in this order, and they just do. Usually. Now notice that they aren't calling it y, because the points aren't all on the regression line. This is their predicted y, right? You tell me that your GPA is 3.5, I'll say, oh yeah, my prediction for your SAT score is 1200. That's my prediction. Y hat. It's supposed to be the caret, the symbol above the 6 on your keyboard. Up, down. This thing the software I used to create this can't quite make them peaked properly. It's just supposed to be up, down. It cut off a little at the top. Now you'll recognize this formula maybe from your formula sheet, which, you know, they're like, here's the equation for a regression line. Wow, it's the equation for a line. Y hat, yeah, you're not going to need this because you know what the equation for a line looks like. Basically, that's why you don't need this. But bear in mind that when you're writing the equation for a line, the hat for a regression line, they insist on the hat. They're likely to take points off if you forget to put a hat over whatever this is. Because they want you to emphasize that that's not the sure-to-be value of y, that is the best prediction of y. Oh no! Everything keeps going wrong. Okay, let's see. So, I'm going to use the one on the left here. So, here's a whole bunch of factoids about this line of best fit and about the data. The average of all of your SAT scores, or PSAT scores, whatever data I could get from you guys, was 1203. Actually, funny fact, the regression line will always go through the exact average. So the average SAT score was 1203. The average GPA score was whatever. It will go through that point, even though there's nobody who's exactly average. The regression line will always go through that average, comma, average point. X bar, Y bar, always. But here is the information you need to build the regression line. My predicted SAT score is 1136 plus 18.5 times x. And sometimes they'll replace y with the wording of it all and x with the wording of it all. So they could very well write predicted SAT score is 1136 plus 18.5 times GPA. Now you'll notice I put the value of R up here. It's a very weak correlation. And now I'm just about to get to explain R squared and what it means. So I'm going to move forward a screen and then back a screen. Alright. What is R squared? Well, you take R, the correlation coefficient, and you square it. Woohoo! What you get is R squared, called the coefficient of determination. That wording won't come up. But what it is, it basically tells you how much, what percent better your line of best, your least squares line is than having no line at all. And I will explain that, and it's not exactly average. You've read the words? Now let me just explain on a picture. Now, I know the average person in my class had a GPA of 1203. So if I met yet another AP Stat student who wasn't in that day, let's say Wilbur wasn't in that day. So I say, hey Wilbur, since you're an AP Stat student, and that's the only thing I know about you, and I know my AP Stat students averaged 1203 on the SAT, my best prediction for your SAT score is going to be 1203. And he goes, okay, cool. And we make a prediction I probably missed by some amount. I don't know how much. And let's say I grabbed a whole bunch of other people who weren't here that day, and I predicted for each of them. I predict for each of them, since I know nothing about them other than their AP Stat student, 1203. And I'm going to miss some high, some low. There will be residuals. I will miss. R squared is how much smaller on average the residuals will be if I use this least squares regression line instead. So, just using the mean of 1203, well, I predict that everybody, no matter what their GPA is, will get 1203. That's not good at all. That is actually really lousy, isn't it? I think I curved upwards. Something like that. So I predict you tell me if a GPA is 1, I say 1203. You predict GPA 4, I predict 1203. Whatever it is, I predict 1203. Well, I will miss. I'll miss this person by that much, this person by that much, this person by that much. All these residuals, right? My stupid regression line assumes that everybody's the same because I'm not using GPA to predict. I'm not really using what I know about GPA to predict their SAT scores. Now let's say I figure out what everybody's GPA scores, and I use that to create a regression line. So the residuals on average get smaller. Let me finish this actually. Here's my dumb regression line. It just calculates, assumes the average is going to be 1203, and everybody's best prediction is 1203, and I miss by a fair bunch. Now, how much do I miss if I use the regression line instead? Well, here I miss by more, here I miss by less, here I miss by more, here I miss by less, 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 I miss by less, I miss by less. I miss by a bit less, I miss by a bit less. Here I miss by about as much one way or the other. Okay, maybe a tiny bit more. Here I miss by a bit less. More. Right? So, here I miss by more. Oh my. But the squares of all those residuals will add up to less with the least squares line. How much less than a flat line prediction, average for everybody? That's what R squared is. It tells you what percent better. So take R and square it, and you get about. So I get to say, hey, I've used this least squares line, and it improved the power of my prediction to figure out what everybody's SAT scores are going to be by 2%. Wow, Mr. B, your regression line really is going to help you predict the next person. Yeah, so like Brittany Lynn, whose GPA is whatever, let's say it's 3.8, it's like 4-ish, whatever it is, using the least squares regression line will probably make me about, on average, if I had a whole bunch of students, 2% more accurate. The squares of their residuals would be 2% smaller if I used the regression line over the long term than if I used the flat line 1203 guess for everybody. That's what R squared is. Let's see, did I handle everything? I did, and I used the word residual. Excellent. The end. I'll just erase that so you can see it for a minute and copy it down without having to pause the video. Well, you'll have to pause the video anyway, because I want to get out of here. But I'm going to record one more video first.